So there's two kinds of basic plastics that can be used. There's a thermoplastic material, which is a polymer you heat up and it softens. You mold it, and then you cool it down. Then you heat it up again, remold it, and keep on going as many times as you like. And there's the thermoset. A thermoset basically is a system that cures on heating. So you heat it up once, and then it stays in that condition. It's like a rubber tire that you vulcanize with sulfur. Once it's been formed, it stays formed. It becomes permanently hard once you exceed a certain temperature and time, a certain energy input. It forms a permanent 3D cross-link network. And the truth is, in the end, you can remelt it, but the temperature required to remelt it is higher than the decomposition temperature. So once you've formed it, it's extremely stable and extremely strong. And that's really where we are in our business, generally thermosets. There are some thermoplastics around, but thermosetting materials are 98% of all that we do in our business. And to produce the thermoset, you have a first stage of making this incompletely reacted pre-polymer. So we mix the resins together and we impregnate them, as I mentioned before. And then we finally convert it to a cross-link product in this pressing phase. That's done by people like us as a manufacturer, and also board shops making a multi-layer board. They produce this board in the end. And the funny thing in the end is, this board I showed you before, it's a single molecule. That is one molecule. So in the end, everything reacts together, and all the epoxy parts will become a single molecule. It's a huge molecule, but it's one molecule. And this 3D cross-link network is what gives it its strength and gives it its reliability and its resilience. So that's really the critical part of this. So we come to the epoxy resin. I know chemistry maybe scares a few people, so I brought some with me. That is epoxy resin. It's a very viscous, gloopy liquid, as you can see. It's sort of moving around. I'll pass it around, but please don't open it, because if it gets on your clothing, it will not come off. It's a liquid. It's formed from epichlorohydrogen and bisphenol A. And the epoxy part, by the way, just for those of you who don't know, is this bit. And there's one either end. So this is called the difunctional epoxy resin. And that's the basis of all that we do. And this resin I'm passing around is used in many industries. It's used in our industry, electronics. It's used for potting electronic components. It's used for coating tin cans. It's used in paints. It's used for structural GRP components. So many things. Of course, it's a liquid, which is not very convenient for our use, so we have to change it a bit. So we take that, and then we add, in this case, a brominated product, which is very similar to what's in the middle, and we form this sort of so-called brominated modified epoxy resin. I've got some of that as well. That's this piece here. So a large lump of epoxy resin. Something went wrong one day, so I managed to get that out of the reactor. And that's now a darker colour, you'll notice, because it contains a flame retardant. It contains bromine flame retardant. And the flame retardant is in there for a very good purpose. On average in Europe, there are 4,500 fatalities a year caused by fire. That's one every 30 minutes. Somebody dies in Europe as a result of fire. The problem with fires start, and in the first 3 to 5 minutes, people are wondering, is it a fire, isn't it a fire? And that's the time they all die, because by the time they realize it is actually a fire, they can't get out, because the whole room has been engulfed in flames. So what you need to do is to buy some time. Electronics, of course, do have high energy sources around them, and they do burst into flames occasionally. So the basic idea is to give yourself a bit of time. So if you take a standard material, without a flame retardant, you have up to 5 minutes to escape from a building, which isn't very long. You imagine trying to get us all out of here, out of the whole hotel within 5 minutes. We spent the first 3 wondering if it's a real fire alarm or not. So we've only got maybe 2 minutes to get out of the building. If you use a flame retardant, you can actually stop the spread of flame, and you can buy yourself 15 minutes. And that makes all the difference. So all the materials that I'm going to talk about and all the materials you're using will contain the flame retardant.